get your CAD design done, what you have as a CAD design, put them together, and you can see directly what are the problems, where are the problems, if it fits or not. If you make this with a scanner, you can also make this with a scanner. You scan an object where you know what is the distance in this object. You scan it with your scanner, compare both data together, and you know where you are. It's very easy, but nobody do. Nobody do. And this is what I always think. First, we have to look a little bit about the interfaces, and nobody looks at the moment at the interfaces. They only look that their part is done well, but not what's coming afterwards.
You scan out. You scan in and you scan out, and you compare data.
The comparison is normally very easy. It's not a hard job. Yeah, a lot of software tools can do this, so industrial software tools. So it's not a big problem. But what I say, nobody use it. Yeah, you can also make a comparison between scanning systems to have one model scanned with a real accurate industrial system, send it everywhere, everybody scan it, and afterwards you know how good the scanner is. But nobody do.
Calibration.
Nobody does.
I'm going to thank Mr. Ralph Riquier for this very nice presentation and present him with his token of appreciation. Good afternoon, doctors, ladies and gentlemen. I would like to welcome you back to this afternoon session. I hope you've enjoyed your lunch. It gives me great pleasure and honor to introduce our next speaker, Professor Dr. Atef Shaker. Professor Atef is Professor of Prosthodontics from Cairo University. He received his bachelor degree in dentistry in 1988, his master's and PhD in prosthodontics simultaneously in 1988 and 1995. Dr. Atef is the founding member of the Egyptian Society of Computerized Dentistry. He has scientific publications in many national and international scientific periodicals. He's a speaker in national and international conferences. Please join me in welcoming Professor Dr. Atef Shaker.
Thank you. Thank you. Good afternoon. Is it working? Good afternoon, ladies and gentlemen. First of all, I would like to thank Dr. Silwadi, Dr. Molova for inviting me for this nice event. Actually, I've been attending this event a couple of times, and I'm happy to share in the participation of the scientific program of this event. First of all, I came from Egypt, and I'm teaching in Cairo University, which is established more than 100 years ago, and we have celebrated 2 years ago the 100th anniversary of our university. Nearby this university, the Cairo University, there are the famous pyramids. I used to go to the pyramids a couple of times, and I saw them from different views. And this is my first time, actually. I was surfing the net, and I saw this beautiful view for the pyramids, so you can see how organized, how accurate they have been built. This is more than 7,000 years ago. And if you see not only the parameters of the... Sorry? Yeah, it's related to precision. Not only the precision of the walls, actually, but each wall, they have a slight obtuse angle. So it's a very precise picture and cannot be seen except from this view. My lecture today will be related to a tough subject, which is the machinable ceramics. I'm sorry, it's a little bit tough, but it's related mainly to the available machinable ceramics in the market. So all of us, they know a lot of products, and they know them by just trade names. And I'm not biased to any one of them, but I'll be clear in explaining what's the difference in composition, properties, and when and where you select your proper ceramic for the proper situation. Nobody can deny that our modern dentistry cannot get away from each one of these: function, contour, health, comfort, speech, and obviously aesthetics. And the era we are living is related to beautiful smiles, and all of us, we are looking for this smile for ourselves and our patients. And the trend in dentistry is related to having ceramic restorations about 30 years ago. Of course, large restorations, they are concerned with the composite aesthetic restoration, but no more composite is indicated for a very large restorations. And nowadays, ceramics is the main perfect material of choice for this kind of restoration. Recent, again, an explosion has occurred in the field of dental technologies as well as materials. And I think nobody is no more satisfied with this kind of restorations. Of course, you know all the abbreviation of this word. It's computer-aided designing, computer-aided manufacturing, and I think we have a lot of systems in the market. And I think many of us, they are a little bit confused about these systems, which we can select and which we can have in our office, and which does what. So I tried to make a little summarize about the systems. So I started to have this scanning, digitizing idea. This is not related to the CAD-CAM, actually. It's just a scanning method about having 3D data from either intraorally, or we can have them from extraoral scanners. So this is not related to the CAD-CAM issue. It's just having data, 3D dimensional data from an object, for an object. And this is not related to CAD-CAM issue. And after having the data, we can either neglect the use of the impression materials, which is a big science related to our field in orthodontics, and by having the object a little bit powdered with the titanium dioxide in order to make it better in reflection, we can have the intraoral capturing images, or we can have the extraoral scanning measures, and we can scan the dyes, the models. Impressions, we can digitize impressions, and we can digitize bites, or we can have the wax or resin patterns. In cases if we scanned the wax or the resin patterns, then there is no more CAD. It's just CAM. So if we have any other scanning option, then we are dealing with the designing. But if we scanned a resin pattern or a wax pattern, there is no more designing again, and now we are dealing with a just milling option. For the designing, all systems, they are related of having the 3D image, and after that, the software, many softwares available, you can design the finish, you can just detect the finish line, and then the software helps you in designing the restoration, which the data can be milled after from any material available in the market. After designing comes the step of the milling. We have 3-axis, 4-axis, 5-axis milling machines, which can mill either metal, ceramics, zirconia, of course, uncentered, centered, titanium, chrome, cobalt, whatever material you can have. And just I'll pass by the available systems in the market so you can get a familiar idea about them. For the CAD-CAM systems, we can classify them again into 3 main groups. The first group is the chair-side CAD-CAM full systems. Second group is chair-side scanners only. And the third group is lab production milling centers. They are a little bit different, and I try to collect the data about the available system in the world. The only 2 systems available for scanning or impression, for scanning, designing, and milling, they are the CEREC 3D and the E4D from 3M SPAY with a couple of partners. So by here you can have the impression, the optical impression, you can design, and you can mill in the same time chair-side. These are the only available options. If we just left the full systems to the scanning system, you only have 4 systems in the world till now. Of course, one of them is the CEREC again, and the E4D again. Lava, they got 3M, they got the Lava COS scanner, intraoral scanner, and the Itero machine, it's only just for intraoral also scanning system. By using one of these 4 systems, no more need to take a direct rubber-based intraoral impression, and this all dealing with an optical impression, of course, with different technologies. One of the examples, like the lava